Hi there, my name is Abbas Khan, student number S1601249. This is the project demonstration video to accompany the report for module CT4021, Introduction to Programming Fundamentals. Now before I get into the demonstration, I'd like to highlight a couple of the key components. The first key component is the 9-volt battery and battery snap that connects to the breadboard. This is used to power the little computer fan here. As the Arduino board can only supply a maximum of 5 volts of battery, this 9-volt battery was required to power the fan, as the fan requires 9 volts. The next key component is the LCD screen that is used to print out the base temperature and current temperature in degrees and Fahrenheit, or Celsius and Fahrenheit. Now, as you can see on the left hand side, we have BT_C and BT_F. This is base temperature for Celsius and base temperature for Fahrenheit. As you can see, the values are 24 and the equivalent 75. Similarly with the other side, CT stands for current temperature, and the top is 20, and the equivalent Fahrenheit number, rounded to the nearest whole number that is 69. The potentiometer over here is used to control the contrast of the LCD screen. The next key component is the LED, which is used as a security light. Now this LED will only power on should the light dependent resistor found here, should the value from that be lower than the target value set in the code. The next key component is the temperature sensor we found here. This is an essential component as it reads the surrounding temperature value. The next key component is the push button found here. This is used to calibrate the base temperature. Now that I've highlighted all the key components in the circuit, I'll move on to the project demonstration section of the video. To begin with, I'll demonstrate the security light. Now, I'll put the camera here and I'll use my hand to modify the value found by the light dependent resistor. Now, as you can see, as I put my hand over the light dependent resistor, the value changes, thus causing the light to turn on. And if I remove my hand, the value changes again, thus causing the LED to turn off. The next component I'll demonstrate is the fan itself. Now, I'll leave the camera here and I'll use my hand to modify the value of the temperature sensor. Should the value change, the fan will start moving as shown, and if I remove my hand, the fan will eventually, after the temperature has decreased, stop as shown. The last component I'll demonstrate is the button used to calibrate the base temperature. Now if I put the camera here, as you can see the current temperature at this point in time is 21, and should I wish to modify the base temperature value to the same as the current temperature, I simply press the button and thus changing the base temperature to the current temperature's value. The reason for the slight variation in value is that the actual values stored in the code are float variables, thus they have the extra precision and decimal values. However, the LCD screen rounds the values to the nearest whole number, thus for the slight change in values displayed. Following on from that key component, as the base temperature is now 20 and the current temperature is 21, the fan has started moving. This concludes the project demonstration video for module CT4021, Introduction to Programming Fundamentals.